All right, I think we can start. Welcome, everyone, and thanks for joining this Mint webinar. Today, we're going to be talking about the OpenAI service on Azure. So myself and my colleague Anke will be presenting on the OpenAI service on Azure. I'm going to take you through some of the functionality and use cases of the solution. I'll show you the AI playground in Azure and what the actual service in Azure looks like. And then my colleague Anke will take you through some of the legal considerations and what actually happens to your data when you use the service, which is very important when using a large language model like the Azure OpenAI service. All right. So the agenda from my side is I'm going to give you an overview of the OpenAI on Azure service. We're going to have a look at the different GPT models. We'll look at some of the service capabilities and use cases. We'll talk about some of the negatives of using GPT, or basically any large language model, which is hallucinations. We'll be going through the costing, and then I'm just going to show you what the service looks like in Azure. Okay. So there's, I think, as we all know, or are all aware of, there's quite a lot of hype surrounding GPT or OpenAI in general. There's a lot of people making some wild statements around the service. And as with any hyped up new technology, it's important to rather just understand how it works exactly so that you can see if this is really relevant for your business and if it is something that you can use within your business and that it would add value to your business. So the service overview. If you go to the OpenAI website, you can sign up for ChatGPT and you can sign up for their API, and you can use the OpenAI service directly. The problem with it is that if you are using it for business services or you're going to be using it for your customers' data, that information is being sent to OpenAI and you don't really know what's happening to it. So in order to alleviate that, you can spin up a OpenAI service within Azure, within your Azure tenant, and that ensures that the data that you're using, your business data or your customers' data, remains private, and it remains within your Azure tenant. So the service can be deployed within your Azure subscription, and your data remains secure. As with any Azure service, you can set up things like role-based access control. You can set up network level security, so only specific IP addresses or even VNets within Azure can access the service. So you can really secure it to ensure that no one else accesses it, or any unauthorized people accesses it, and that data stays secure. There's also custom AI models that you can fine-tune with your specific data. So if you want a solution that runs on top of your company data, like let's say a chatbot that would answer questions based off of your data, you can use a customized model and you can run training on your data within your Azure tenant. It also has built-in responsible AI to detect harmful use so that people don't use it in a harmful way. And you can also do prompt engineering if you're using the service. So if you are using it as part of an application, you would train the models and it would sit in your Azure tenant and you would access it via an API. And with those API requests, you can add in some prompt engineering to say that, you don't have a sense of humor, keep it business, professional, and you can really limit the way that it responds so that people can't use it as you would with the publicly accessible ChatGPT service. So the models that are available, we've got GPT-4. So this is this improves on GPT 3.5 and 3. And it's quite a big improvement. The amount of data points that the GPT-4 model has been taught on is impressive. If you do have a paid-for service on OpenAI, you would have been able to play with it already, and you will see that there's quite a significant difference in the response quality of GPT-4 over GPT-3. Then we have GPT-3. So this is a series of models that can understand and generate natural language. And it also has ChatGPT model as part of GPT-3. So we'll look at the models at a later stage, but there's quite a few different models within GPT-3 that you can select from, and they range in size. So they are all alphabetical, so from Ada to Cushman to Da Vinci. And as you go down the alphabet, the models become bigger, so the responses can be more complex, and they can also accept more tokens. But they are also more costly to use. So if you are going to use a model for your specific business requirement, it's normally advised to start with a Da Vinci model, which is the biggest model, and then fine-tune it and potentially go down to a smaller model. The smaller models are also more responsive, so there's less latency and you'll get a much quicker response, and it's going to cost you a lot less. So if you do need a very advanced response, then sure, use a big model like Da Vinci. But if you need basic responses and you train it on your company's data, then you can use things like the Ada model. But we'll have a look at those models in a later slide. Then there's also codecs. So this can take text as input and generate code. So you can translate natural language to code. Codex has been discontinued by OpenAI specifically, but it is still available as a model within the Azure OpenAI service that you can use. Now, you'll notice these screens at the bottom here. So firstly, if you want to spin up a Azure OpenAI service in your Azure tenant, you do need to go through an approval process. It's a fairly basic process. You just need to, you'll receive a link to a Microsoft form, and you just need to fill out a few questions regarding what you will be using the service for. And then within a couple of business days, that'll be validated and you'll get access to the Azure OpenAI service. In addition, if you want to get access to GPT-4, you also need to go on a wait list. And you also need to go through a validation process. So I myself am currently on a waiting list, waiting to get access to GPT-4, and hopefully within the next few business days, we'll get access to that. So that is just something to consider if you want to use the service. It's not generally available, and you need to go through an approval process, but it is a great time to start using the service and testing it and building out a proof of concept within your business, so that once it's in general availability, you already have a solution that you can just deploy. The service is also only available in specific regions in Azure. So it's available in East US. I believe South US or Central US is currently stopped due to high demand. And then it's also available in Western Europe, and GPT-4 is available in Central France in their data center there. So just keep that into consideration. The service will be sitting in a different location. It's not currently available within the South African data centers or other data centers outside of those. And then also within the models that you get within the service, they are also only available within specific regions. So you need to go read up on that and just have a look and understand before you actually start testing it. Okay, so if we just have a look at the model, so as mentioned, GPT-4, you currently need to go on a waiting list, but they do have two models available within GPT-4. So you've got the general GPT-4, so that can take 8192 max input tokens. I'll also explain what tokens are when we get to costing. And then you get the 32K GPT-4 model, which takes 32,768 input tokens. So if you've got large documents that needs to be maybe summarized, or you need to create a product description for a specific product, and you've got large amounts of text that you need to input to a model, the GPT-4 32K can take up to 32,000 tokens. Then you've got the GPT-3 model. So you'll notice that this is called Da Vinci, Curie, Babbage, and Ada. So these vary in size, and it's alphabetically listed. So Ada is the smallest model, and it'll give you the most basic response, but it's also the quickest because it is so small, and it's also the cheapest. So as mentioned, when you start testing the service in Azure and using it for a business requirement, you need to consider that, maybe you don't just need Da Vinci because it might be more expensive, where one of the smaller models might suffice and you can just use those. Then you've got the ChatGPT model, which is built on GPT 3.5 Turbo. So this is the model that I think the general public is most familiar to, because this is the OpenAI's ChatGPT model that people are using, but you can have that in your own tenant in Azure and use it on your specific data, and also do prompt engineering for all of the inputs. Then there's Codex. As mentioned, OpenAI has discontinued this, but you can still spin this up within your Azure tenant, and that also ranges in size from, you get Da Vinci and Cushman as well. So if you need natural language to create code, you can use Codex. And then there's also the embedding models. There's quite a lot. There's a big list of those. I haven't listed all of them here, but you can find it on Microsoft's site. I'll share the links. So this is for similarity embedding. So clustering regression, you can use it for anomaly detection and visualization, text search, context relevance, and so on. Okay, so if we just have a look at the models in a bit more detail. So within the GPT-3 family of models, you get these specific models. So you'll notice the regions. So certain models are only available in certain regions. So East US, South Central US, West Europe, and then the GPT models are also available in France Central. So you need to consider the model you're going to be using, and also where your data will be residing. As time goes by, of course, these models will become generally available, and we should start seeing them being available in more regions. But currently, they are only available in these regions. And then so there is currently a hold on South Central US as well, due to just high demand in the region. So really, it's only available in 3 different regions currently. So GPT-3, there's quite a few. You'll notice that there's multiple ADAs and there's multiple Da Vinci. So where it has text in front of it, these are specific for text generation. And where they have code in front of them, you can use those as Codex models. Right, so where does this service sit within the bigger Azure ecosystem? So if you've got specific machine learning requirements or a very specific use case for your business where you need potentially some anomaly detection, you can still use machine learning to build those scenarios out. But then on top of that, you've got customizable AI models. This is where the Vision API sits in speech and language. So All the cognitive services sits within that, and that's also where the OpenAI service sits in. On top of that, you've got your scenario-based services. So the bot services, the cognitive services, form recognizer, video indexer, and so on. And then you've got your application platform and your actual applications. And all of these top layers leverage the lower layers, like the customizable AI models and potentially your ML models. If we look at some of the service capabilities, so firstly, content generation. So think call center analytics. So automatically generating responses to customer inquiries. Chatbots in the past were potentially a bit basic, I would say. But if you leverage the OpenAI service, you can get much more conversational chatbot, much more human-like and a lot more intelligent. You can generate personalized user interfaces for your website, and then text summarization. So call center analytics, again, summary of the customer support conversation logs. You can also do see basically the temperature of customer responses. So are customers angry? Are they happy in general? You can do that across any type of text input. Then subject matter expert document summarization. So I've personally used this to summarize case studies, just to get the salient points out of case studies. If you don't feel like reading the whole thing over and over again. And then also social media trend summarization. With the codex models and also GPT 3.5 Turbo and 4, you can use code generation. So converting natural language to SQL for telemetry data, converting natural language to query data models, and then also code documentation. And then semantic search, so searching reviews for specific products or information discovery and knowledge mining. And then there's quite a few sort of text-based and code-based service capabilities that you can use. Classifying text, extracting insights of text, or summarizing articles, and creating outlines of essays. There's quite a few different scenarios that you can use the service for, and the best is to actually spin up the service in Azure if you've got a specific business case and start building out a POC and testing the service. So one of the negatives with the GPT models, or basically any large language model, is hallucinations. Because it can generate text so well, it can generate incorrect information. Sorry. It can generate incorrect information that if you don't know the content of, or if you're not an expert, you would consider it to be correct. I'll give you an example of that when I show you the actual service at a later stage, but that is something to consider. If you are using the Azure OpenAI service, you can, as part of the prompt engineering, you can say that, if you don't know, then don't answer. I see we've got a hand up. Okay, seems to be down again. So you can say that if you don't know the answer, then don't respond, or say that you don't know the answer, instead of still trying to give an answer. This doesn't always work. I do have an example that I'll share with you later when we have a look at the service where it gets it completely wrong. This has improved significantly with GPT-4 over GPT-3. Okay. And then costing. So costing, especially with the text-based models, is token-based. So tokens can be words or just chunks of characters. So the word tablespoon would be 2 tokens, table and spoon. But a smaller word like fig would remain 1 token. So if we look at the DaVinci and Ada text-based models, per 1,000 tokens, that is what you will be paying. And for DaVinci, that is quite a bit more. So this is why it's important when you are building out a proof of concept, or if you're testing the service, to make sure that you're not just using the DaVinci model because it's the biggest one, but you can actually use one of the smaller models like Ada or Cushman or Babbage. So you need to test with those different models and see if they suffice for your requirements. Otherwise, you will be spending more money where you could be saving quite a bit more. GPT-4, you can see it's also, it is a bit more, and also the costing is a little bit different. So it's still token-based, but you've got prompt and completions that you pay for with GPT-4. Then for the DALL-E model, so this is the image generation model. So you can give it text inputs, and we didn't actually cover it in one of the previous slides, but you can give it text inputs and it'll generate an image for you. So this is $2 per 100 images that you are generating. And then the fine-tune model. So if you are going to run a model on your own data, fine-tune it for your specific requirements, you still have the per token costs, but you also have training per compute hour. So the longer that the training takes on your data, the more you will pay for it. In addition, there's also hosting costs that you need to consider. So again, there's quite a significant difference between the DaVinci, which is the biggest, and the smaller Ada model that you need to consider. Okay. Are there any questions on this before I show you the actual service within Azure?
Hi, yes, it's Angelo here. Just back to your costing, particularly on the fine-tuned model, the computing cost. Are there sort of any studies or frameworks that have been established that could help one sort of forecast for what that looks like?
I'm not aware of any specific studies. There are some Microsoft considerations around it that I can share with you, Angela, but no specific studies really. So are you referring to, if we are going to train this on our data, if it's
I'll
X
use
amount of gigs.
your example. So where it's call center data that one wants to link up to a website to sort of give suggested answers or whatever the case may be, what that would translate to when one tries to forecast what that looks like.
Right.
From a cost perspective, yeah.
Yeah, so you need to consider the actual size of the data. That's obviously the first thing, because that's going to be the actual hours that it's training, and then also the size of the model. So the DaVinci model, because it's so big, will take longer to train. So that can escalate quite a lot if it's a couple of gigs of data that you need to train it on. But I will share some links on some of the Microsoft considerations around training it on your own data.
Thank you.
Right. All right, let's switch over to the Azure portal. And let's just sign in again. So if you create this, if you're familiar with the Azure portal, the OpenAI service looks like any other really. You would search for OpenAI here, and you would spin up an instance, your own instance. And you can then specify things like role-based access control on the service. You can specify networking. So if you do need only specific networks to access the service, very similar to other Azure services. You can also view your keys and endpoints here for the actual API. But where it becomes a little bit different is you get the AI playground, or the OpenAI Studio, that you can go and test the service in, and you can give it some prompts. And this is also where you do your actual training. So If we go to deployments, you'll notice that I've got a model deployment. So you need to specify your model first that you want to deploy. If we create a new deployment, you can see that there's quite a few. And these are some of the ones that we've discussed in the slide deck. So you need to decide what model you are going to be using. As mentioned, if it is a new solution, you're not quite sure if, let's say, the bigger DaVinci model will suffice, or if it's going to be Ada, maybe start with DaVinci first, and then try and scale it down to see if you still get sufficient responses when you get to a smaller model like the Ada model. You'll give it a deployment name, and then the actual model is deployed. Okay. Now, if you go to you'll get access to the chat playground and the completions playground, and this is where you can actually run some tests against the model to see how it would respond. So within test, you can do some prompt engineering. So let's take a basic example. So I'll just take it as is, and I'll say, tell me a joke. And it'll come up with a joke. I'll say, you have no sense of humor. And I'll ask it to tell me a joke again. And now it's not really going to give me a response. I can also say that keep all your responses professional. And if you have it trained on your specific data, you can also limit it to only give responses on your data. An example of hallucinations. So this is something that you don't get in GPT-4, but this is a GPT 3.5 model. So I'm going to ask it what weighs more. Okay. Okay, so what weighs more, a pound of feathers or a pound of bricks? Both a pound of feathers and a pound of bricks weigh the same amount, which is correct. But now if we switch this up, it will think that this is a trick question, and it will actually give us the incorrect response. So let's go to, okay, so 2 pounds of feathers. 2 pounds of feathers or a pound of bricks. Now we'll see that 2 pounds of feathers and 1 pound of bricks both weigh the same, which is incorrect. And it basically thinks that this is a trick question. As mentioned, that's not something you get with GPT-4, but it is something to consider. So you also need to say, if it is generating text for you, let's say it's creating product recommendations for you, or product marketing. You give it inputs of the specific product, and you ask it to create a brief description of a product for product marketing. You need to also say that, if you're not sure, say so, or do not answer, because it will continue to give you a response even though it's not actually based on specific facts. You can also, from this, if you are going to use this model in an application and use this as a backend, you can view the actual code from here. So you can see, let's say we go to C#, you can see the specific library that you need to use in your application. So it's the Azure AI OpenAI library. This is currently in preview. So if you are using Visual Studio and you're adding it as a NuGet package, you need to say allow pre-release libraries, otherwise you won't see that. And it gives you the complete code on how you can call it with your API keys and get a response from it. And you can also do that in Python and so on. In addition, there's also the completions playground. So there's a few examples here. So let's say generate an email. So you can add in your own text here, or you can use the examples to get an idea of how you can use the model. You can also specify the tokens. So as mentioned in costing, the tokens, the costs are directly linked to tokens. So if you want to limit that, you can also limit the tokens. So it also gives a shorter response. Okay. And this will actually generate a response for us now. Okay. There's also the temperature, which ranges from 0 to 1. So if it's on 0, it's going to be very factual based. It's not going to be very creative, so to say. Whereas on 1, it will be the most creative. And you can also specify all of these parameters as part of your API calls when you're using this as a backend service. Okay. All right, so that's a very quick and brief overview of the Azure OpenAI service. I hope this gives you an idea of sort of what the service looks like in Azure, how you can use it, and the different models, the costing, how the costing works. I'm going to hand over to my colleague, Anke, who's going to go through some of the legal implications and considerations when using a large language model like the GPT models. But if you do have any further questions on the service or so, please reach out to us and we can assist with doing a proof of concept or anything like that.
Thanks for the insightful presentation, Ed. Good morning or good afternoon, everyone, depending on which region you're listening from. My name is Anke Claassen. I'm in-house legal or legal eagle, so to speak. And I'm very excited to be co-presenting for you today. Before we get started, I would just like to take the opportunity to thank each and every one of you for taking the time to listen to our presentations today. I think the Azure OpenAI service collaboration is a very exciting development. And as part of the presentation, I will discuss the measures and tools that you can utilize in order for you to mitigate the risks so you can capitalize on the good, namely the opportunities. Let's get started, shall we? As you've no doubt seen from Edward's presentation, the Azure AI offering service offers powerful capabilities to help you build and deploy your AI models. However, as with any technology that deals with data, it will be essential to mitigate risks by prioritizing data privacy in order to ensure that sensitive information is protected and used responsibly. But good news, the Azure OpenAI service does provide robust features and tools to help safeguard your information throughout the AI development process. Let's explore some key aspects of data privacy and security in the context of the Azure OpenAI service. The focus of this presentation will be to enable you, the audience, to minimize the risks associated with AI developments by protecting your data and ensuring its privacy. To this end, it is worth noting that without security, there can be no privacy. I would like to encourage you, the audience, to think of data privacy as the objective and data security as the means by which this objective will be reached. We will start this presentation by investigating what measures are available to address data privacy and then move on to discuss data security and lastly looking at the best practices that can be implemented by companies such as yourselves. As you can see on the screen, data privacy is the protection of personal or sensitive information from unauthorized access, use, or disclosure. In this section, you'll take a look at the types of data and how it will be handled. Secondly, the legal rights and permissions to consider. And lastly, the importance of knowing the data residency and compliance of each region where your data will be stored. Firstly, what types of data does the Azure OpenAI service process? As you can see on the screen, it is prompts and completions, training and validation data, as well as results data from the training process. When we look at prompts and completions, you will see that prompts are submitted by the user and the completions are then output by the service via the completions and embedding operations. I'm sure that you'll be very glad to know that the prompts used during these operations are not used to train, retrain, or improve the models in any way. When we turn to training and validation data, you can provide your own training data consisting of prompt completion pairs. This will be for the purposes of fine-tuning an OpenAI model. When we look at results data from the training process, you'll see that after training, the service will output metadata on the job, which will include tokens, as discussed by Ed, which process and validate scores at each step. The training data provided by the customer is only used to fine-tune the customer's model and is not used by Microsoft to train or improve any Microsoft models. So that is also good news from a compliance point of view. Now for the big question, how the data will be handled. We will look at training, validation, and training results data, as well as the fine-tuned OpenAI models and prompts and completions. When we look at training, validation, and training results data, the training is stored, data is stored in Azure storage, is encrypted at rest by Microsoft, managed keys within the same region as the resource, and is then logically isolated with the Azure subscription API credentials. The uploaded files can be deleted by the user by using the delete API operation. We turn next to fine-tuned OpenAI models. These trained fine-tuned models are stored in the Azure storage in the same region, encrypted at rest, and also logically isolated with the Azure subscription. These models can also be deleted by making use of the delete API operation. When we look at prompts and completions, it will be important for you to take note that the data is encrypted. It will therefore only be accessible to authorized Microsoft employees for two purposes, namely for debugging purposes in the event of a failure, and secondly, to investigate patterns of abuse or misuse, to determine if the service is being used in a manner that violates the applicable product terms. So when a customer is approved for modified abuse monitoring, these prompts and completions data are not stored, and thus Microsoft employees will not have access to the data. So this is something to bear in mind. And we now turn to a very important question, which I'm sure is on everyone's minds, namely what measures are in place to prevent abuse and harmful content generation. So as you saw on the previous slide, the Azure OpenAI service stores prompts and completions for the service for up to 30 days. So the reason for this is to monitor for content and behavior that suggests that the service may violate the applicable product terms. So authorized Microsoft employees may then review the prompts and completions data that has triggered the automated systems to investigate and verify potential abuse. So in the event of a confirmed policy violation, a customer may then be asked to take immediate action to prevent further abuse. If there's failure to address the issue, then it will result in a suspension or termination of the Azure OpenAI resource access. So as customers, you may request to modify the content filtering and/or abuse monitoring. If you are then approved and remain in compliance with the requirements, then the prompts and completions won't be stored. So in practice, this would mean that if the system identifies harmful content, the customers will receive either an error on their API call if the prompt was deemed to be inappropriate, or the response will signify that some of the content generation was filtered. We turn next to legal rights and permissions. So from a compliance point of view, to comply with certain privacy regulations, such as the GDPR, you may need to obtain and document the consent of data subjects to collect or use their personal data, as well as to document the distribution of required privacy notices. So good news, the Azure infrastructure can help host customized privacy notices to help you meet those compliance requirements. The Azure Active Directory can also be used to request and obtain the consent to use such data. In addition, the Azure SQL database can be used to document the data subjects who have granted their affirmative consent. So therefore, Microsoft product services and tools are already available to help you as customers find and act on personal data, to respond to data subjects' requests, and importantly, in terms of detecting and responding to breaches to meet the compliance needs. In addition, Microsoft provides you the capability to access, delete, and export certain customer data through the Azure portal, and also directly via the pre-existing application programming interfaces or user interfaces. The Azure activity log can also be used to document the actions in Azure, such as who initiated the operation, when it occurred, what the status of the operation was, and you can use the Azure activity log for your right operations and in order to be informed of the operations and other relevant properties. So this is all valuable information to take into consideration. We now look at data residency and compliance requirements. So data is sent to and from the service, and this is encrypted via the SSL and TLS protocols, and the data is then stored in Azure. It is automatically encrypted using the Azure Storage Service encryption. Additionally, Azure OpenAI also provides you with the capability to define access controls and permissions. So it helps you to restrict access to data based upon user roles and responsibilities. Azure OpenAI also automatically encrypts your data when it's persisted on the cloud and helps you to meet your organizational security and compliance commitments. So normally by default, your subscription would use Microsoft Managed Encryption Keys. There's also the option to manage your subscription with your own keys called Customer Managed Keys, CMK. In ICU, we do love our acronyms. So CMK offers you the greater flexibility to create, rotate, disable, and revoke the access controls. And you can also audit the encryption keys to protect your data. So you need to consider that you must use your Azure Key Vault to store your customer managed keys. You can also create your own keys and then store them in the Key Vault, or just use the Azure Key Vault APIs to generate keys. The cognitive services resource and Key Vault must be in the same tenant, but they can be in different subscriptions. Just as a side note, before we move on to data security, I would just again like to emphasize the value of understanding the data that is used to train the models, and to therefore ensure that it does not contain any personally identifiable information or other sensitive data unless it's absolutely necessary and appropriate. So if it is a requirement, then Azure OpenAI service does, however, provide you features like data masking and de-identification techniques to help you protect sensitive data during the training process. We now turn to the second topic, namely data security. As previously indicated, data security involves the measures to help you protect your data from unauthorized access, use, disclosure, alteration, or destruction. We also can take a look at the measures that are available, the industry security practices, namely, and then secondly, what features can be used for monitoring and logging activities, and in how you can manage access. When we look at industry standard practices, users can use measures such as the multi-factor authentication, and then, of course, the role-based access control, which Edward spoke of briefly, while using the Azure OpenAI service. This can be done to authenticate and authorize access to the service. This will help to prevent unauthorized access to your AI models and data, so it's very important to take note of. The Azure OpenAI service also regularly monitors and audits systems for vulnerabilities and applies patches and updates to mitigate potential risks. Encryption of data is also a very important element of protecting in case of breach. So Azure does provide various encryption models. This would include the site server encryption that uses service managed keys, and then your customer managed keys in the Key Vault or on the customer controlled hardware. We now turn to part B, namely using the features for monitoring and logging activities. So the functions that are available here include auditing of API calls and diagnostic logs, which can be used by companies to detect and investigate any security incidents, very important. Additionally, Azure OpenAI service also has built-in threat intelligence and machine learning-based anomaly detection to help you be proactive to identify and respond to potential security threats. In addition, the Azure OpenAI service also integrates with Azure Active Directory, which allows you to manage access to the service, by using the authentication and authorized mechanisms. This provides you with a central way to manage user access and also enables a single sign-on and helps you to enforce your security policies across your organization. We'll now look at managing access. I would like to address this by saying in order to truly achieve this, the users must be identified and it needs to be determined which roles should have which rights. Basically, the principle of least privilege. And then implementing the principle that users are granted access only to the information that is strictly speaking necessary for them to perform their individual tasks. Further to this, it will go a long way in making it office policy that administrative privileges are only given to a small number of individuals. So the mechanisms of Azure can help you to achieve this. For instance, the Azure role-based access control can be used to limit the use of specific data. For example, you can change it to read only. It can also help you enforce the separation of duties and enable you to determine fine-grained roles and responsibilities and to grant access only to the users that need to perform their jobs. There's also the functionality of the Azure Active Directory privileged information, which can be used to minimize the number of people who can have access to the customer data and can help you to discover, restrict, and monitor privileged identities and their access to resources. You can also use the service to enforce on-demand, just-in-time administrative access when so needed. And then we also have the Azure Information Protection, which can help you control both who can access a document or email message and control where that document can be edited, restricted to read only, or is allowed to be printed or forwarded. It also uses Azure Rights Management to help you ensure that your data remains protected no matter where it's stored or with whom it is shared. But this is all very valuable considerations to keep in mind. So we legal professionals are known as the proverbial troubleshooters. So I've taken the liberty of addressing some questions that I think you may have at this stage. So if we look at the first question, namely, can a customer opt out of the logging and human review process? I've inserted this question because it may happen that some customers may want to use the Azure OpenAI service for a use case that would involve the processing of sensitive, highly confidential, or legally regulated input, but where the likelihood of harmful outputs or misuse would be low. So these customers may then conclude that they do not want to or do not have the right to permit Microsoft to process this data, whether it would be for abuse detection or due to their internal policies or applicable data protection regulation. So in order to address these concerns, Microsoft allows the customers to meet the additional criteria and can attest to specific use cases to modify the Azure OpenAI content management features. So that is something that is to your disposal. The second question is namely whether customer data would be logged with content filtering. So no, content filtering functions differently than the abuse monitoring, and the logging or storage of data would not be needed. This is because content filtering would work by applying algorithmic detection to the prompts and completions at inference times to determine if the content should be filtered. So no data will be stored at rest as part of this process, and for this reason, there will not be a need for human review of the prompts or completions that have been subject to the filtering. So this is just a good side note to remember. The third question is what is covered by customer managed key encryption? We spoke about it briefly. So customer managed keys, as I said, offers you greater flexibility in terms of creating, rotating, disabling, or revoking access controls. But you can also order the encryption keys to protect your data. So CMK would then encrypt all the customer data stored at rest in the Azure OpenAI service, such as the data that would be uploaded for fine-tuning, except, of course, for the data that it would be logged for 30 days, as we discussed previously in terms of the abuse monitoring. Another question I'm sure is on everyone's minds is what would happen if Microsoft would need access to your data? So most operations support and troubleshooting performed by Microsoft or sub-processes would not require access to your customer data in any way. But in those rare circumstances where the access would be needed, customer lockbox would provide an interface for you as a customer to review and to approve or reject customer data access requests. This lockbox would, for instance, be used in cases where a Microsoft engineer would need access to your customer data, whether in response to a customer-initiated support ticket or just a problem identified by Microsoft in general. In the Azure OpenAI service, the customer lockbox would apply to all customer data that is stored by the service, such as the data that was uploaded for fine-tuning, except, of course, for the prompts and completions that was logged and accessed for the purposes of abuse monitoring. Another important question, which I think most compliance-minded individuals would want an answer to, would be whether the customer data is used to train the OpenAI models. So notice this is not the case. The customer data is not used to train, retrain, or improve the models in the Azure OpenAI service. But this is good news to remember. And then the final question, which I think is also very, very important to answer, would be whether customer data that is processed by Azure OpenAI would be sent to OpenAI in any way. So no, it would not be. This is because Microsoft hosts the OpenAI models within its existing Azure infrastructure, and therefore all the customer data that is sent to Azure OpenAI would remain within the Azure OpenAI service. Lastly, we will look at the best practices. To this end, it will be valuable to remember that when using the Azure OpenAI service, it is important to follow best practices to ensure data privacy and security. Here are some recommendations, such as understanding and familiarizing yourself with the applicable data privacy regulations, such as the GDPR, and ensuring that your use of the service complies with these regulations. Secondly, to secure your data, this can be done by implementing strong security measures, such as using the SSL or TLS encryption for data that is in transit, encrypting data at rest, and implementing the authentication and authorization mechanisms that we spoke of. Following the principle of least privilege, you can also grant access to only those users who so need it, and then limit the permissions to the minimum necessary to do their tasks. Thirdly, to use masking and de-identification techniques if you need to use, if you really need to use sensitive information. This can involve techniques like tokenization, encryption, or aggregation to anonymize the data before it's used for training or inference. And this is a very important one to remember. And then fourthly, to regularly monitor and audit, you can set up your monitoring and logging mechanisms to help you track activities and detect any potential security incidents. This needs to be done regularly. And you can also use the built-in logging and auditing features that's already provided by Azure to gain insights into the API calls, the model performance, and security events. Fifthly, and I think this is a crucial one, is to educate and train your users, including your developers, your data scientists, and other stakeholders about data privacy and the security best practices. This can be done by providing training and resources in order to ensure that they understand the importance of protecting data and using the Azure OpenAI services securely. And then lastly, to regularly review and update your permissions to ensure that only the authorized users have access to your AI models, and to remove access for users who no longer need it. This would be done based upon the principle of least privilege. So in conclusion, you can safeguard your information and ensure your AI models are built and deployed responsibly by following best practices, understanding and complying with privacy regulations, implementing the robust security measures that are already available, and regularly monitoring and auditing your AI pipeline. As is clear from this presentation, the Azure OpenAI service provides you with the built-in features and tools to help you protect your data, but it is nevertheless also important to implement additional internal security measures and to educate your users to ensure the privacy and security of your data and AI models. Remember, data privacy and security are ongoing efforts that require vigilance and continuous improvements to stay protected. This concludes the presentation. Thanks for being such a wonderful audience. I will now turn the remainder of the presentation over to Ed. Thanks all.
Thanks, Anke. That was very insightful. Thanks, everyone. So we do have a form that you can complete. And I guess our call to action is if you are interested in the OpenAI service, and if you want to do a proof of concept internally, or you just need some assistance with it, please reach out to us, or we can set up a session to discuss it in a bit more detail. But thanks for your time. Really appreciate it. And please reach out to us if you have any questions. Thanks.